Hi everyone, welcome to Multimedia Communications class. We shall proceed with our discussion with respect to Module 2. Module 2 title is Multimedia Information Representation. We know there are four types of multimedia: text, images, audio and video, and all these have basic forms of signal representation. Text and images, they are represented in digital form. Whereas it's nothing but a binary representation, a combination of binary numbers. And whereas audio and video, they are analog form representation. It means they are not readily available in the binary form. They are continuously varying waveform signal. They are continuously varying waveform signals. Okay. So in this class, we shall try to concentrate on what is meant by analog signal, how to represent it, and how to convert this analog signal to digital signal, means the binary representation, and again convert back this digital representation again to analog form. Okay, so we are going to concentrate on topic named digitization principle. Okay, this is the first topic we are going to discuss in module 2, digitization principles. Okay, in this we are going to talk on how to convert analog to digital, that is nothing but encoder. We are going to learn encoder which convert analog signal to digital signal. Okay, next we are going to learn the next topic, topic called decoder. In the digitization principles only, what does it do? It converts digital signal back to analog signal. For example, I am speaking now. My voice is an analog signal. It is continuously varying. If I am speaking fast, you can able to hear my voice with less time. If I am speaking slow, you can able to hear my words very it requires more time. Okay, it means my voice is ranging. It's varying over the time. Okay, so and you are also hearing my voice, but we are communicating with the help of a system. I am speaking here. Okay, I am speaking here. Okay, my voice is going like this, analog signal, and I'm using a system, The system only understands binary number, and you are a person who is listening to me. Okay, you are listening to me, correct? And he wants to hear my voice, correct? So this my voice is analog form, and you are hearing my analog signal, means my speech, my voice, but we are using a system. Okay, this system only understands binary representation. So we need to make this medium to understand our analog signal. So we need to convert this analog to digital. So we require an encoder here. And again the receiver has to hear my voice, means you need to hear my voice. So we need to convert from the system he needs to hear. We need to convert this digital form to analog form. Okay, we need to convert again digital back to analog form. This conversion of digital to analog form is done by a decoder. Hope I have cleared myself what is meant by digitization principles and why we need to learn this encoder and decoder. Encoder will convert the analog signal to digital signal, and decoder will convert the digital signal back to analog signal. And digital signal is nothing but the binary representation, binary numbers will be involved. Okay, now before going to this encoder and decoder, we shall see some basic things which are necessary to make our understanding better. Okay, so we are going to learn the representation of analog signal. What is meant by analog signal and how does it get represented? Okay, what are the components involved to transfer this analog signal from receiver into the transmitter? Sorry, from transmitter into the receiver end. Hope I made myself clear. Okay, so we are going to first learn about analog signals. It means in this class we shall concentrate on analog signals. Yes, now we are discussing about analog signals. Please make a note of it. First we shall state what is analog signal. Analog signals are nothing but the continuously time varying signal. It means we are going to have an x-axis and we are going to have a time on the x-axis. It is denoted by t and its unit in seconds. Okay. Okay, yes, on the y-axis we are going to have signal. That signal is nothing but our analog signal, and we are going to measure. Okay, we are going to call its variation nature as amplitude. Okay, please see, this is a signal amplitude on the y-axis. I am speaking, you are able to hear. Sometimes I speak low and sometimes I speak high. Sometimes I speak fast. So my signal is getting variation. Continue. Okay. So there is a variation in my signal level. So we are going to call this variation. Okay. We are going to call this variation as a continuously varying signal. Okay. This is my analog signal. You can see this is my analog signal. It is varying over the time. So we are going to call analog signal as a continuously varying signal. Continuously varying signal with time. Okay, this is the meaning of the analog signal. This is not directly 0 or 1 like a binary form. Okay, so this is analog signal. Please make a note of it, and that figure name is analog signal continuously varying with the time. Okay, what I am marking here, these are called amplitude. Okay, these are all called the amplitude. They are varying with respect to them. This may be time t1, time t2. Okay, they are varying. This is not constant. Okay, so in general, the analog signal is nothing but a signal which is varying continuously over the time. Please make a note of this. This may be time t1, time t2. So this is amplitude. Is it clear? I think you are clear with the analog signal. Next we shall see what is how can we measure, how can we able to represent this analog signal. This analog signal can be represented using a mathematical technique called Fourier analysis. Okay, we can able to tell this analog signal is continuously varying over the time. Okay, for an infinite possible points. Okay, so the Fourier series will tell that analog signal is a signal which is varying over the time continuously, and it can have infinite number of signal frequency it can have an infinite number of single frequency signals. Okay, so analog signal is a continuously time varying signal. It can be represented with the help of a mathematical technique called Fourier analysis, where Fourier analysis will show that an analog signal can be made up of a possibly infinite number of single frequency sinusoidal signals. Okay, so now it's time to look whether any components are involved. Yes, there are components involved called frequency component. Okay, so to define an analog signal or to know about the analog signal, we have two frequency component. One is the low frequency component, and other one is called the high frequency component. Why we require these things, we shall see. Okay, so first I will please look at the figure. I'm going to low frequency component. What is meant by frequency? Frequency means the number of times, the occurrence of something over a period of time, or within a time. Okay, so this is called frequency. So on the x-axis I'm marking time t in seconds. On the y-axis I'm naming it as a frequency. Frequency means occurrence of something over a period of time. Okay, now I'm marking time t1 here, and time t2 here, and time t3 here. Okay, I'm going to draw a vertical lines, a dotted lines. Hope my screen is visual. I hope I'm also audible to you. Yes, see, I'm speaking slowly, and my words are reaching you slowly. Okay, I am speaking slowly, my words are reaching slowly. This is my word 1, this is my word 2, this is my word 3. See, at time unit 1 you can able to hear my word 1, word 2 in time 2, T2, and word 3. Means if I speak slowly, you need some more time to hear my words. This is called low frequency component, reaching of signal. Okay, with more time. This is called low frequency component. And next is Next one, please observe the diagram. I am drawing the below the low frequency component on the x-axis time scale t. On the y-axis, I am going to write it as a frequency component. I guess by this time you know what this might be. This might be high frequency component. Obviously, there are two components, low and high frequency. When I have drawn a low frequency component, this should be an high frequency component. Then I am going to take the same time units t1 and t2 and t3. Okay, yes. Now I'm going to speak very fast, and you can able to hear me or you cannot able to hear me. So you can able to see the variation in my previous few seconds the explanation, where I spoke slowly, one by one, word by word. So I mentioned it as low frequency component. Now I'm speaking fastly. Okay, today we are going to talk with respect to the digitization principles, and in that we are going to discuss analog signal, encoder and decoder. So within one span of time you can able to hear my most of the words. Okay, what I'm drawing? I am drawing my words, nothing but the analog signal. Okay, you can see within one time unit you can able to most of my analog signal, most of the analog words. Okay, so see, in this duration, this time t1 duration, you can see 1, 2, 3, more than once this analog signal. Okay, you can see in this time duration t1, you can see more number of analog signals are there. It means if there are more number of analog signals within one span of time, one period of time, we are going to call it the high frequency component. If in a period of time there is a less number of signals are passing through, we are going to call it the low frequency component. I hope you got the difference between low frequency component and high frequency component. So this entire cycle, okay, 0 degree and 180 degree and 360 degree, this entire cycle, okay, we are going to call the above signal is 0 above is called positive and negative. This entire signal is 360 degree. We are going to call it as a one time period for low frequency component. Whereas for high frequency component, if I take this one start and one end, means the starting of the signal. Okay, so I can tell this as the high frequency time period. It is less. Okay, you can see the time period for high frequency component is less compared to the time period for the low frequency component. I hope you got the difference between the low frequency component and high frequency component. Frequency means number of times within a period of time, t1, t2, how many times the signal comes, how frequently the signal comes. Okay, so in a period of time, if signals are coming more, it's called high frequency. If signals are coming less, it's called low frequency. Is it clear? Yes, we shall proceed to the next thing about the signal component. Okay, so signal bandwidth, signal bandwidth. So signal bandwidths are nothing but the range of signals are passing over a time. Signal bandwidth are nothing but the range of signals can be passed over a time. Range of frequencies of sinusoidal components, low frequency component, high frequency component, which can be passed within a channel, within a specified channel. So on the x-axis we are going to draw frequency. Why we are drawing frequency? Why are mentioning frequency? Anyone? Okay. We are mentioning frequency because we can able to see. We are going to talk, and more number of words will be there, and those are nothing. Each word we can call it a letter, a word. We can call it as a signal, analog signal. Okay. So these signals are called range of signals, and we can call it the range of frequencies. Is it clear? Okay. So that's why we are going to write this x-axis as frequency. Its notation is f, and it's going to measured in units hertz. On the y-axis, we are going to have the signal amplitude. Okay, signal amplitude. I hope all of you are concentrating on this class. Okay, so we are trying to understand the concept called signal bandwidth. Is it clear? Signal bandwidth. What is meant by bandwidth? Okay, there will be some container. It can able to store. So within this container, it can able to store an area which can able to store. Okay, yes, that's the general meaning of bandwidth. Okay, band means we are going to measure. We are going to depict like this. Okay, this is an area. Okay, this is an area where we can able to pass our range of signals. So this is called channel bandwidth. This is called channel bandwidth. Means it channel bandwidth which allows the range of signals to pass through it. Okay, so it has got a low frequency component and high frequency component. Okay, means start signal as well as the end frequency. Okay, so low frequency component is denoted by FL and high frequency component denoted by FH. This is called signal bandwidth. This is called signal bandwidth, means which allows the range of frequencies of components. Range of frequencies of components. Which type of component? A sinusoidal component. This is called sinusoidal signal. Okay, sinusoidal component. Is it clear? Yes, sir. We shall have two examples. One is a speech signal, which I am speaking, you are hearing, it's called speech. Another is music. Music means playing a song or an orchestra or your famous thing, famous word called DJ. Okay, orchestra. Okay, now I'm speaking, you can able to vary my voice, you can able to hear my variation in voice in some range, but not very bit loud as like a music. In music you can able to increase the volume so that it can reach from ground floor to third floor or fourth floor, and okay, some range, some distance, some far away distance, some kilometers distance. Okay, whereas my speech cannot able to reach the far away distance in kilometers. It can reach, my speech, my audio can, my talk can reach only few meters unless and until you speak over a microphone. Okay, yes, so that is the difference between speech signal and music. So we shall see the ranges for speech signal. So the speech signal within the bandwidth, it has got a low frequency of 50 hertz, and it has got a high frequency of FH is equal to 10 kilohertz. Okay, 10 kilohertz. What is this? This is the speech bandwidth. Speech bandwidth. Please draw neatly in the notes in the examination, not like me. This x-axis is frequency F in hertz. This is signal amplitude. Hope you can able to understand my voice. Okay, now this is about speech. Next we are going to look the ranges for music. Music range in allowable range is FL is 15 hertz, minimum is 15, and its maximum is 20 kilohertz. 20 kilohertz. What is this width is called? The allowable range of frequencies which can able to pass through in transmitting the signal over a device. Okay, this is music bandwidth. Still you could not able to understand what is meant by signal bandwidth. See, we are talking now, we are using a system and it has to pass through from my mouth to through the system and to the ear. So through the system it has to pass through. No, so there are some protocols defined, means a channel. In that channel, it can able to accommodate only such kind of signals, such kind, only few ranges, few. For example, you have seen water bottle. No? Yes, water bottle you have seen. So this is called some container, allowable. Okay, it can able to like a pass through. Okay, hope you got the point cleared. Okay, so in the signal bandwidth, it's nothing but the range of frequencies of sinusoidal components which are allowed to pass through it. Okay, and we have seen, we have taken two examples, speech and music, and the range of the speech minimum is 50 hertz, maximum is 10 kilohertz, and for music signal minimum is 15 hertz and maximum is 20 kilohertz. Okay, you need to draw these figures for this analog signal in the examination if you want marks. Okay, next thing in the analog signal is bandwidth channel. Bandwidth channel. Okay, previously we saw signal bandwidth. Signal bandwidth means the range of frequencies. Bandwidth channel means what should be that range. Okay, how much signal you can able to pass through that. Okay, here also our x-axis will be frequency F measured in hertz, and y-axis we are going to have signal amplitude. Not much to remember. Okay, y-axis, x-axis. Okay, please see, if my signal, if I'm speaking, if I'm speaking or playing a music, if my signal is spanning from FL to FH, some minimum low frequency component to high frequency component. What is this? This is my, pardon me, this is my FL and FH. This is the signal bandwidth. What is this? This is my signal bandwidth, means my speech signal bandwidth. Okay, I'm speaking like this. with this tone. When I am trying to communicate to the receiver, and I'm using a system where that system can able to accommodate. It is defined with some limited channel width, and its low frequency is FL prime, and its high frequency component is FH prime. Means in this channel, in this device, it can able to allow channel bandwidth. It can able to allow only this FL prime and FH prime frequency components. But my signal, but my speech, my audio is having more bandwidth. Okay, and the system channel allowable bandwidth is less. So because of this, some of my speeches are getting lost. What is getting lost? Some of my frequencies of signals are getting lost, and only few part of my speech is getting transferred over this channel bandwidth. So what is happening? My signals are getting cut off here. My signals are getting cut off. Some of my voice, some of my words are getting cut off. So here FL prime and FH prime denote the allowable channel bandwidth through a system, and this FL and FH signifies the speech or music of a person, okay, which is more. And because since signal is bandwidth is more and channel bandwidth is less, channel bandwidth allows only the signal frequencies falling between FL prime and FH prime. And those signals which are more than FL prime and FH prime, they are getting cut off, they are getting lost. This is called signal degradation, or quality of signal getting degraded. Is it clear? Okay, so what we are going to call, this is called band limiting concept. Band limitings, okay, band limiting concept. Okay, so we are going to call it the band limiting channel. Band limiting channel. Band limiting channel means the channel bandwidth is less, or it is as per the protocol, but the signal which is trying to pass, speech or music, it is more. So band limiting channel, it is going to allow only the set of frequencies which can be allowed between FL prime and FH prime. Is it clear? So FL prime and FH prime are called as, FL is called low frequency component, FH is called high frequency component, FL prime is called low frequency cutoff, low cutoff frequency, and FH prime is high cutoff frequency. So these are all about your analog signal. So in analog signal, what we are going to explain, one is what is meant by analog signal. It is varying with the time, okay, the amplitude. And next we are going to talk about the low frequency component, and obviously we need to show that time, and high frequency component. These are the things we are going to show in analog signal. Plus, apart from this, we are going to talk about signal bandwidth. We are going to talk about signal bandwidth. We are going to mention depict the signal bandwidth for signal bandwidth for speech and music. And lastly we are going to mention about the cutoff frequencies if signal is more and channel frequencies are limited. This is signal and this is channel, and channel bandwidth is limited. The signals, only the frequency of signals which can able to pass through the channel are allowed. Remaining signals are cut off or getting lost. So these are the graphs we are going to represent in our diagram with explanation. So with this we conclude our today's class, analog signals. In the next class we shall meet for encoder and decoder explanation. Yes, thank you for attending the class.